Hi, everybody. This is Tony Lockwood. I'm in Cleveland, Ohio, and we're at CAASE 18, co-hosted by Digital Engineering and by the Nathans organization. If you're not right here, you're square, man. Okay. Now, I have an interesting and intelligent guest here, and I would like you to introduce yourself, who you work for. I'm into simulation. What do you guys have for me?
I'm Will Mars. I am the founder and president of Endurica, LLC. We do durability solutions for elastomers. That means a couple of things, but we have software that lets you model complex loads and compute the impacts on durability, and we also have testing services and testing instruments. Basically, we're a one-stop shop for durability for soft materials.
That's right, and you just came out with a new digital twin interface, I believe?
Yes,
right?
yes, yeah. So, our one of our newest products is a thing called Endurica DT. And DT stands for Digital Twin, if you like, or it's actually a little play on words because it also stands for DT as in sort of an incremental, like an increment of time.
Right.
Okay. And the idea is that it allows you to, where our traditional workflow has been, you tell me the loads, and then I'll tell you how many times you can repeat that, and that's kind of a one-shot thing. The DT is more of an incremental workflow. So for example, you send me a recording of your loads for one day. We'll accumulate the damage for that period. And then tomorrow you can send me new loads, completely different. And the next day, new loads. And so it becomes a streaming, real live updating analysis of how damage is accruing in your product or structure or whatever. So that's Endurica DT.
Very good. Yeah. Now, this sort of analysis, and I know you also work with FE Safe. Yep. Correct?
Yeah. So Dassault System, the Simulia people, they distribute a product called FE Safe Rubber, right, that is basically our fatigue solver wrapped and integrated with their fatigue interface.
Right. Very good. Okay. Now, what are you hearing from the people out in the field who, come to you? We need you to help us through this. We need a new feature. We need this, that, or the other thing. What are you hearing from them about? What are the challenges they're facing, and you're helping them solve?
Yeah. Well, one of the ones we're going to be one of the ones that we've heard a lot about is there's some problems where the load histories are much longer than what you can really simulate in a finite element model, and so there's a real need for fast computing, models, and in fact, one of the newer things that we're working on is going to be aimed in this direction, where it's going to be a thing called EIE, Efficient Interpolation Engine. Okay. And what EIE is going to do is it's going to allow you to take a small number of finite element simulations and kind of remix them, interpolate them to generate a much longer stream of information that you can use for fatigue analysis.
Right. Good. And then does the high performance computing or any of that get in here with this, or
sure.
Help, with the models are probably getting larger and more complex.
They're getting larger and more complex, and we're always looking at how do you make the code run faster? How do you make the code take advantage of multiple parallelism? We're always pushing it on that.
Yeah. Do your clients get into the democratizing, as the expression goes, or they You're not quite ready to pass that off onto other people.
No, I think that's an important idea. I mean, for a long time, a lot of these things have been very specialist types of capabilities, but ultimately some of these problems have been solved, and what we do is we package them up, and the measure of success, I think, for us is when anybody can anybody can get the benefit from them. So yeah, I think there's a lot in this idea of democratization.
Yeah, very good, very good. What do you envision the next couple of years happening with you? I know you're working on a new product, and for the benefit of your sanity, I'm not going to say when are you releasing it.
Thank you.
But what do you see in the next couple of years coming down the road? The technologies that are going to affect you and your users. What put on your?
Yeah, I mean, in my space, I think people. I mean, obviously, fatigue is one thing that's important, but another, there's sort of, I guess you could call them parallel issues that go along with durability, like aging of a material, right? Not only what happens when you fatigue it, but what happens if you just sit it in the sun for a year? So that's
and fall apart.
Exactly. Right. Yeah. So there's those kinds of things.
That must be a tough nut because the environment has a lot of variables.
Yes, and it becomes it is. It's a very I would agree. It's a tough nut. Yeah.
I'm sorry. I start thinking about it. Oh man, gee.
Yeah.
Now you're working on a complex analysis, but you can't have your software so complex that nobody can run it except for the guy who did the program.
Right.
How do you work through the complexity of your interface and things like that?
I think this is something we think about a lot. In fact, I think for rubber and for durability, for rubber, there's been metal fatigue codes for like 20 years, 30 years. Yeah. We're the first ones to do it for rubber, and one of the key things that we've had to focus on has been the fact that rubber is full of what I call special effects. Right. It's got these nonlinear behavior and strain crystallization and rate dependence and all this stuff.
Right.
And of course, when you give a new user a code that can do all of these things, most of them don't necessarily know all of the special effects from the beginning.
Right.
So part of this is the design of the code. Part of it is training. Regarding the design of the code, one thing that we kind of have adopted as a philosophy is in our code we offer analysts a selection of, for each phenomenon there's a selection of models that go from very, very simple models that are maybe very broad brush and maybe not very accurate, but it's just a single parameter, or it kind of locks down some assumptions for you, so you can get things right out of the box without knowing much.
Yes.
And then, but then as you get more sophisticated, or as you have projects that have more scope or more demand for accuracy, we offer much fancier models where you can measure everything, and then you can have that be represented very accurately in the model. So that's on the code side. On the training side, for a long time we've had two classes, one on experiments, one on analysis. How do you measure everything that goes into the code? What are the buttons you push to get all the different effects? Yeah. We've recently launched a third class that's really not aimed at simulation people. It's really more aimed at the people who formulate rubber compounds. So people who are making the recipes and this sort of thing. Yeah. But it's compounding for durability. And people who use this class, that class is organized. How do you select your polymer? How do you select your filler? How do you set a cure system? And the class is organized around a person who takes this class is obviously going to learn some things about how to set up a material, but the ideas are all basically things that they're going to, when they come to the code,
Right.
the same knobs and levers are there, and so
Right, yeah.
for a long time there's been kind of a gap between the mechanical people and the chemistry people,
Right.
and so this tool is kind of a bridge builder between these two separate disciplines.
That's cool stuff.
Yeah.
And I'm not going to do a pun about the rubber meeting the road, but but we're out of time here, and your website is just
Endurica.com.
Endurica.com, and we will have that web address for anybody who didn't get it. And I want to thank you very much for your time.
Thank you,
and
Tony.
This is fascinating stuff. Thank you.
Thank you.